Dasher said, I'm Paul Bielski. I lead the what's called the NASA Exploration Systems Simulations Development Team. And so a lot of the simulation capability you're going to see here was developed by people that I work with. So, enjoy it all. It's a lot of fun stuff. What we're going to show you today up here is our lander simulation. So for folks who are not familiar with what NASA's been doing in this realm, there's a program out there called the Human Landing Systems Program. It is tasked with landing humans on the lunar surface, starting with Artemis 3 mission. So not the one that we just announced crew for yesterday, but the next mission, which is, I think, another couple of years away. Past that point, there will be a series of missions that land on the lunar surface. What you're going to see here is that particular simulation. This one is based on what we call a government reference model. So generally when we start off kind of scoping out programs, we don't know who's, especially in the new commercial universe we live in, we don't know who the winners of the competitions are going to be. So we design essentially a simplistic version of the system we want to develop, and we use that simulation to help us understand what the performance of the vehicles needs to be to perform that function, so we can make sure that that information is encoded into the contracts that get written by for the vendors. Let's see. By just letting the lander land itself on the surface. What you're looking at here are a couple of displays that represent some of the functionality of the lander. What you're looking at here is an out the window view. So for this particular lander design, basically we're flying with the feet forward on it and relying on our back. So the lander is actually pretty much horizontal. It's got about a 60-degree attitude there. And so as we approach our landing site that's represented by the doghouse on that other display, our vehicle's going to pitch up and then we're going to rotate down and land.
Oh, wow.
I'll show you.
Because I'm going to show you guys, show you real quick what to do while the sim is still setting up. Okay. You saw that little camera in front of you when you were looking at it, right inside. This is the camera you'll be looking at, or the monitor. Well, your left hand is a stick and your right hand is another stick. Don't move this one on the right, move the one on the left. You'll be moving this green crosshair towards the start of the this. So that green crosshair, that's the one you're moving. And this is where we train the restaurants. Up and down. So red line, you were doing this, you let go. Yeah, no, that's a no-no. So this is how I drove it. That's how the astronauts do it. Okay, that's how they practice. But I've been working here for quite a while, so I've been practicing.
Like what do you do? Yeah,
Thank you.
Okay.
Hello. Wow.
So somebody who hasn't flown something yet?
Both of us.
Okay.
You want to go first?
Whatever, yeah.
So this is the beta dome. We use this for Orion work. So what we're going to be doing here is docking Orion with the gateway vehicle. that's in lunar orbit. So Gateway is kind of the lunar space station that is in the process of being built. So we're going to start off about 9 meters away. And as you can see here, we've got our range of 9 meters. We have a camera mounted in the docking hatch window, and that's what we're seeing here. You don't have enough information out the windows here to be able to actually complete a docking.
Right.
So you really depend on that hatch window. So what I'll have you do first is hit the button next to zoom. And then you're going to find this green crosshair. You want to line it up with the black cross here.
Okay.
Anywhere inside that circle is good enough.
Okay.
You don't need to do anything on the rotational.
Nothing.
Everything is this guy here.
Okay.
If you want the crosshair to go up, it's up. Down moves you down. Left is left. Right is right. Pushing in increases speed. Going out decreases speed.
Got it.
What I recommend doing is giving it 6 ins. Just pulse it in 6 times.
Okay.
Let's see here. Okay. Then go to down. Use that twizzle knob to highlight fine.
Fine. Weird. Oh, got it.
And then hit ENT.
Okay.
That'll give you finer control. So this is going to be a pulse. So you hear the thrusters fire.
Got it.
So Orion is fully automated, so the crew shouldn't have to take over manual control. But it's important that they have some control if there is a problem with the automation. So what they'd probably do first, let me move you in a little bit closer here. They would fly the translation first. If they had problems with the vehicle holding orientation, they'd take over flying the attitude control as well. It's a lot harder to fly if you have to do both, and these are good pilots, they can handle it, but we don't want to overwhelm the crew right away if there's an issue with the vehicle. Okay, so I think you're all set here. Go ahead and hit that button next to zoom. Go ahead and give it 6 ins on the stick, so pulse it in 6 times.
Inside?
Yeah. Okay, so your predictors are moving out. Right now, these are separated by a minute. So it's saying we're a little more than a minute from docking. Go ahead and hit that button next to pick tap. Use that twizzle knob to highlight fine.
This?
Yep. It's a little jumpy. Then hit ENT. That's going to give you a smaller pulse size for finer control. So you'll have tighter control and you can save fuel. So now you can do your up and your left to try to line it up. As you can see, it reacts, but it reacts very slowly to what you're doing.
Do I hold it down?
Nope, it's a pulse. So right now you're trending in the right direction. So you don't want to do any more inputs in that direction. And at some point you're going to have to do your down and your left or your right to stop that motion. This is really a hands-off operation compared to running the arm, driving a rover, that sort of thing. A lot more watching than actual commanding. So one of the things the crew likes is pulse mode for. They can count their pulses. So if they had to do 3 to start moving one way, they'd probably have to take them out once they reach their destination. All right, so you're pretty good right now. So that was an attitude firing. Sometimes they'll line you up better, sometimes they'll hurt you. But the attitude firings are just managing orientation. It does not care that you're trying to translate. For a fully automated approach, it has to care about translation and rotation. And what you see here for switches and knobs, that's pretty much it for Orion. Remember, shuttle, Apollo, they had buttons and switches all over the place. A lot of that functionality has been moved into the displays. They left the survival switches here. So
Here are the two views on this TV. I'm the one on the left, so you see me moving my head. You see the Earth there, the sun, somewhere over there. Look at it to the right. So one on this side, one on this side, and there's a virtual fence that'll come up so you don't walk into each other or walk into the outside of the carpet. To virtually move your left hand, touches the thumb pad right here, that's forward, back, right, left, wherever you're pointing, that virtually walks you. The triggers, close your hand so you can pick up rocks and play catch.